Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this will be the second video from the polynomial. Okay, so this time around is another part of polynomial which is about remainder and factor theorem. Yeah, so I think these two are not so that difficult, and actually 4.3 as well. Okay, which is solving cubic, because these are actually they are actually related. Okay, from the long division, okay, can be used in factor theorem, can be used in remainder theorem, or there's also another method that we will uncover in factor theorem and remainder theorem, which also be useful enough actually to be um to be actually being used for the solving cubic polynomials, also solving cubic equations. Yeah. Okay, so going back to this, okay, so let's see what will be the questions that we're going to go through today. Okay, so we'll be going straight to example 9. Okay, so this one, we are going to remainder theorem first. Okay, so as we all know, okay, remainder theorem from the long division. Okay, when we divide, it means there's actually a number left, right? That's all. Okay, from the long division, when we divide everything, there's actually a number below. Okay, expression below means it's not equals to zero. Okay, there's actually some number remaining. That's what we call remainder or remainder theorem. Okay, so before we go on further, okay, I will uncover the another method besides long division that we can use, and it's actually slightly easier. Okay, we can use for factor theorem or remainder theorem and factor theorem. Okay, right. So this is what we call the example when we have an fx. Fx means when the whole thing lah is actually a prefix to replace y equals something. So fx, okay, don't worry if you see fx. Okay, fx is just something to replace y equal to something lah. Y equal to x square or 4x square, 4x cube, and so on. Okay, so given that this 4x cube minus 5x plus 1, okay, find the remainder when fx or the y, whatever tadi, okay, is divided by x minus 2. Okay, so rather than doing all those long division, okay, you have to do just now, okay, which is quite lengthy, and not to mention, okay, the one that we say the minus minus, right? There can be a careless mistake somewhere. Okay, another one that you can, the another method that you can do is, which is shorter, okay, you need to find that number. When you find that number, you substitute inside here, you get your remainder. Okay, so how to get that number? So first, you have to solve this, whatever that is being divided with. So how you want to solve that? So just put let x minus 2 equals to 0. Okay, so you can solve it as easy as it is. So x equals to 2. Alright, so once you get that x, okay, sub x equals to 2 into fx. Okay, you will find out that actually that number, when you replace that, you will get your you will get your remainder, which is very, it's actually shorter than we have to do that long division. Okay, so let's see. So 4x cubed 2 cube minus 5 2 plus 1. So 4 2 4 8 8 minus 10 plus 1 32 minus 10 plus 1. Alhamdulillah. Alhamdulillah. Okay, you get 23. Okay. So 32 minus 10 plus 1, 32 minus 10 is 22 plus 1, 23. Okay, so how do you verify that this thing is actually correct? Okay, let's try to do the long division and see if we can get the same answer remainder as 23. Okay, let's try. 4x cubed minus 5x plus 1 divided by x minus 2. Okay, so as we all know, okay, we have to try the first one here, eliminate with the 4x cubed. So what times x equals to 4x cubed? Okay, so find that number or find that expression. So in this case, it's 4. So in order to get x and x cubed, we have to find x squared. So 4x squared times x, you get a 4x cubed minus off. Okay, the automatically minus. Okay, you get a 4x cubed. And then don't forget, okay, we have another one here, minus 2. So you get a minus 8x squared. So remember, we do not have an x squared on top here. So it's as good as 0x squared. Okay, and then don't forget, okay, there's also a automatic minus. Okay, there's now 4x squared minus 2 times minus 2, you get minus 8x squared. So minus 8x squared, you get plus 8x. Okay, so you see, you can see that, it's quite a lengthy one, right? So bring over, minus 5x plus 1. Okay, so now the next one is 1 times x becomes 8x squared. Okay, so it's as good as 8x, isn't it? Right? So 8x. So plus 8x. So you get an 8x squared. So with the automatic minus, okay, you get 8x squared minus 8x squared equals 0. Then don't forget, there's a minus 2 you have to times with. So minus 16x minus 2, 8x times minus 2, you get minus 16x. And then minus automatically comes out. So minus 5x minus become plus. Minus 5x plus 16x. Okay, you get 11x. And then don't forget, the plus 1 comes down. Okay, so what times x equals to 11x. Okay, this one is good, easy. Okay, you get an 11. Okay, so 11 is plus 11. So 11x. Then forget, there's a automatic minus. So 11 times minus 2, you get a minus 22. So 11x minus 11x, 0, 1. Okay, minus comes in, the automatic minus. So 1 minus minus 22 becomes plus 22. So 22 plus 1, you get 23. See? You get the same. But at the expense of time, okay, and the length. Okay, the length is, okay, it's longer lah. Okay, using a long division. So, ladies and gentlemen, this is the new step, okay, that I would want to introduce lah. Okay, it's as easy as when they say it's divided by something, you just need to solve what is divided, that thing equals to 0. So whatever that you get, the x, you just need to substitute into your fx or y or whatsoever, and then you get your remainder. Okay, that's right, and it's proven lah. Okay, the remainder here using this method and using the long division method we just learned earlier is actually the same. Okay, you will get the same. Okay, sounds cool, right? Okay, so this is another method that you can use lah. Okay, for this one. All right. Okay, so the next one. Okay, so So again, the same thing, leaves this thing, the x squared, 4x squared minus px plus 7 is a remainder of minus 2 when divided by x minus 3. Again, the same thing. Okay, I think from here, since we see that that method is actually shorter, I think I would, from here onwards, I will use that finding the x. Okay, the method of finding the x is shorter. So I will use that now, okay, instead of the long division. But long division is still uh, usable, it's still helpful. That's why in the last chapter, okay, in partial fractions, okay, there's none other than long division. You still need to use it. Okay, so it's still quite very, very important. So for now, I will pause the usage of long division because why? Of time factor lah. Alright. Okay, so using this one, x minus 3. So let's solve this. X minus 3. So x minus 3 equals to 0. So x equals to 3. Okay. So as we all know, sub x equals to 3 into fx, or into the expression. So in this case, okay, maybe not fx lah, into let's write down as the whole thing. Okay, so we write down the whole thing. We know it's 4, 3 square minus b times 3 plus 7. Okay, and then they say leaves a remainder of minus 2. So once you put inside the expression or inside the fx or y equals something, you will get a remainder of minus 2. So this whole thing, you will get a remainder of minus 2. But in this case, we cannot get it because why? There's actually a p, there's an algebra inside. But we know this whole thing, the expression, we get minus 2. So 3 squared is 9. 9 times 4, 36. Minus 3b plus 7 equals to minus 2. So 3 squared is 9. 9 times 4 is 36. Okay, so this one, you just need to solve your algebra lah, as usual. That's 3p. So minus 2 minus 7 is minus 9. Okay, minus 2 minus 7 minus 36. Okay, so minus 9 minus 36, you get a minus 45. So p is equals to 15. Okay, so you see, it's quite short. Okay, rather than you have to do the whole list of long division, okay, it's quite massive. It's quite, and then because the minus and minus some more, you need to, have to make it a plus, so on. Okay, so I think this one is shorter and hopefully is doable for you lah. Right, for now. Okay, let's continue on to the next example. The next example is all about factor theorem, but the way of doing is actually the same. Okay, now when we say about factor theorem, okay, now the question is remainder. When you put inside the whatever the x is, okay, the value of x, you make it equal to 0, you get the x, you put inside, there's still a number. That's why, because it's called factor theorem. But when it's, remainder theorem. But when we say factor theorem, there won't be any no remainder. So it means whatever that you sub inside equals to 0. So that's the main difference. Okay, the main difference is one has a number, a remainder, okay, factor, no remainder. Okay, but the working is still the same. X minus 1, okay, you have to divide, right, with x minus 1. So let x minus 1 equal to 0. So x equals to 1. Okay, so we have to determine that whether this x minus 1, okay, when you put in the x equal to 1 inside, you get equal to 0 or you get still a number. So when there's a number, means x minus 1 cannot be a factor. So put inside. So sub x equals to 1 into fx. Okay, so 3, 1 cube minus 1 square plus 3, 1 plus 2. So 1 cube is still 1. So times 3, you get 3 plus 1 plus 3 plus 2. Okay, so 3 minus 1 is 2. 2 plus 3 is 5. Plus 5 plus 2 is 7. So you see, okay, you still get a number. Okay, you say get a number is not equal to 0. Right? So you get 7. Okay, means it's a remainder. So x minus 1 is not a factor. Okay, because why? You don't get equals to 1. Sorry, you don't get equals to 0. Okay, you still get a number when you substitute that x that you get this. Okay, simple so far. Okay, it's just a matter of, okay, right now when we stop here, this at this juncture, just need to know remainder, you get a number, and balance, factor theorem, no balance, equal to 0. Okay. Okay. Right. So continue on. I think this one should be the last. Yeah, correct. Okay, so because why this might be the question, okay, that might be linked to the 4.3. Of course, it's not yet linked, but I will give you a very thinking question that maybe you can think about. Okay, bring into 4.3 lah. Okay, about how to solve cubic. Okay, because it's cubic right now. It's ax cubed. Okay, so right now it says exactly divisible by x squared minus 2x minus 3. Okay, now the question is exactly divisible. Means we divided by x squared minus 2x minus 3, isn't it? So, as we all know, okay, same thing. X squared minus 2x minus 3. Okay, just now all this while was x minus 1, x plus 2 equals 0. So this time round is equals to 0. This become a quadratic. Okay, so using your calculator, okay, right. Okay, so x squared. So I try to get the right one. Okay, so 3, 1, 3, x. So minus 3, yeah, got it. Minus 3, minus 2x, got it. Okay, so you get, okay, based on your sec 2 style, okay, you get this 2, so x equals to 3, x equals to minus 1. Okay, as part of your the value of x that you need to put inside, okay, your expression. Okay, so sub x equals to 3 into the expression. Okay, so a 3 cube minus a 3 square plus b 3 plus 6. So 327a, okay, minus 9, 3 square is 9, 9 times 8, 72 plus 3b plus 6. Okay, now the question is, okay, when you put inside, it says exactly divisible. It means it's actually what we call factor. Okay, when it's a factor, okay, when you put inside the expression, you get equals to 0. This part. Okay, you need to take note of this part. So because why? Okay, you might oversee this part. Because it's a factor. When you put the value of x inside the expression or inside the fx or whatsoever, must take note when it's a factor is equals to 0. Alright, so bring over, okay, sorry, and bring over the others to the other side. Okay, we get 27a plus 3b equal to 72 minus 6. Okay, you get 66. Okay, 27a plus 3b. So the same thing, sub x equals to minus 1. Okay, you get a 1 square minus 8 1 square plus b times, sorry, minus 1 minus 1, sorry, this one is cube. Okay, make sure it's correct, everything. Okay, yes, so 8a times minus 1 cube, minus 1 cube is minus 1, minus 1 times a, you get minus a, minus 1 squared is a positive 1, positive 1 times minus 8, you get a minus 8, minus 1 times b minus b plus 6. Again, the same thing, equals to 0. Okay, and then you find out that, oh, okay, so a, then I make it positive lah, a plus b for both sides. So a plus b minus 8 plus 6, the number is now on the left side or on itself. Minus 8 plus 6, you get a minus 2. Okay, so it seems that, oh, we have a, b here. Okay, so maybe this one I think is can divide by 3 if I'm not mistaken. Yeah, you can divide by 3. So divide by 3, you get 9a plus b equals to 66 divided by 3 is 22. There we go. Yeah, okay. So up to you how you want to do the simultaneous equation. Okay, for me I will minus off lah because we have a b here. We have a b here, I just minus off. Okay. Okay, just minus off. So 9a minus a, b minus b, 22 minus minus 2. So 8a, b minus b is 0. Okay, so 22 minus minus 2. Okay, so 8a is equals to 24. A is equals to 3. Okay, so now find the b. So 3 plus b equals to minus 2. B equals to, bring over, minus. There we go. Okay, so find the value of a and of b. Okay, so that's how we get it. Okay, factor theorem. Okay, in this case, they are actually expanding. Okay, what if divided by a quadratic equation? But it still works the same thing. A quadratic equation, you just need to equal to 0. Find your x using your sec2 style. Okay, find the x equal to 1. And then same thing, the value put inside, equate it equal to 0. Okay, so at the end of this, okay, do you notice? Okay, I just want you to take notice of this because this thing might be, this will be in 5.3, sorry, 4.3. Okay, right now it's cube. Okay, we already found out that, okay, this thing is a factor. Okay, as we all know, okay, like quadratic, okay, x squared minus 2x minus 3, okay, we'll have two factors, x minus 3, x plus 1. But when there's a cubic, how many factors will there be? Okay, if quadratic, power 2, there should be two factors. If cubic, there should be three factors. Okay, so right now, using this expression, okay, we already have x minus 3 is one of them. X plus 1 is another one. So how to find the last one? That will be in 4.3. Okay, that will be 4.3, which we will be discussing later on next Monday onwards. Okay, as for now, okay, this is how we do factor theorem. Okay, this factor theorem will still be used, okay, in cubic, how to solve cubic in 4.3. Okay, so it's still very, very useful. Okay, how to solve cubic also can be used using long division. Okay, so it's long division is quite useful as well. Quite is actually an alternative lah. Okay, right. Okay, so I think that's the end of factor theorem and remainder theorem. Yes. Okay. So before I go, okay, I want to share again, remind you all what you should be doing. Okay, as the end of this. Okay, so all right. So this part, please take note. Okay, of this part. Okay. Okay, so we already have done okay, by now you should be watching at least two interactive videos. Okay, I think this one is the second one. Okay, so from these two interactive videos, okay, there will be a try it out assessment, maybe Google form, maybe a Microsoft form. Okay, so you have to complete them by before next Monday. Okay, on Sunday, hopefully you have submitted it. Okay, so by next Monday, so that you all are prepared. Because why next Monday, I will just give any O-level questions that has got factor theorems, remainder theorems, and even long division as well. Yeah, so that will be the what we're going through. Okay, for next Monday lah. Okay, next Monday. Okay, we'll be trying to see, okay, demonstrate the proficiencies that you all have by watching these two videos. Okay, and try to help hopefully do the polynomial division, the long division actually, remainder theorem and factor theorem within 5 minutes. That's actually with 100% accuracy, of course, because we're talking about maths. Okay, so that hopefully on next Monday we'll be doing it lah. So hopefully with these two videos, it can actually help you get the understanding in doing long division, remainder theorem, and factor theorem. So that next Monday you're more prepared. Okay, with this, inshallah. Okay, so thank you so much for watching the video. Okay, of course, I hope it can be done. Okay, okay, I hope it can be done. Okay, we have ample time and Thursday and Friday. If you're not going for Raya, Saturday, Sundays even. Okay, hopefully it can be done before next Monday lah. It's not that bad. I mean, inshallah, the Microsoft form. Okay, I will try not to have a lot of questions, at most 5. Okay, so hopefully it's not a taxing task lah, inshallah. Okay, all right. So thank you so much for your time viewing the videos. Okay, all right. So hopefully you can look out for the Google or Microsoft form for the assessment tryout after this. Okay, to complete before next Monday. Okay, thank you so much, and see you again next Monday, inshallah. Assalamualaikum warahmatullahi wabarakatuh. Take care.